Okay, the first thing you're asked here is to find 10 factorial over 6 factorial. You should pause and do that. Here I've written it out. 10 factorial, of course, is 10 times 9 times 8, etc., down through 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, which occurs up here as well as here. So dividing this into this, we just get 1, and that just leaves us with 10 times 9 times 8 times 7, which incidentally multiplies out to 5,040, but we leave it in this form until the very last step, because this form gives us information about exactly what the expression means. Now, let's see, what does the expression mean? I've got some blanks to choose here, there to fill. 10 times 9 times 8 times 7 is the number of ways to choose what from what. You should fill in those blanks. You should have filled them in. And it's the number of ways to choose 4 objects from among 10 objects. In the same way, the 12 times 11 times 10 times 9 is a number of ways to choose 4 from 12 objects. And that choice is in order. Okay, so another question here. 23 times 22 times 21 times 20 times 19 equals what factorial divided by what factorial? Pause and figure this out. Okay, I'm going to go on. In the same way that dividing 10 factorial by 6 factorial left you with 4 numbers, 10, 9, 8, 7, we could divide 23 factorial by an appropriate factorial to get rid of everything from 18 down to 1. How are we going to do that? Well, we divide by 18 factorial. We need to get rid of 18, 17, 16, etc. down to 1 from the 23 factorial, and this will leave us with the product of these numbers. Now, what does 23 times 22 times 21 times 20 times 19 represent? It represents the number of ways of choosing 5 objects from 23 without replacement and where order matters. In the same way that this represents what it does and what you know it does from previous clips, and in the same way that 10 times 9 times 8 times 7 is the number of ways of choosing 4 from 10 in order. Now, let's say that we want to rank 20 people out of 100. And by ranking, I mean who's number 1, who's number 2, who's number 3, etc. So how do we do that? Think that through before you look at what I did. Okay, if we rank 20 out of the 100 people, how many possible rankings are there? Well, there's going to be how many choices for the first? 100 choices. Having ranked the first person, there are 99 people from whom to choose the second, and 98 for the third, and so on, down to the 81st person. Okay, and that of course would be 100 times 99, etc., down to 81. And if you count those on your fingers, 100, 99, 98, 97, 96, etc., you'll find that there are 20. Okay, to get that product, you would divide 100 factorial by 80 factorial, and the reason for that should be clear in terms of this example and other examples that we've seen. So that's the number of ways to rank 20 people out of 100. Now, if we want to just choose 20 people out of 100 and unordered, say 20 people to form some sort of a group without any kind of a ranking, then what would we have to do? Well, there are 20 factorial ways to order 20 people. Okay, so the same 20 people could appear in 20 factorial different ways. That's a huge number, incidentally, but so are these. So we would divide the number of ways to put them in order by the number of possible orders. So number of ways to put them in order is 100 factorial over 80 factorial. We divide that by 20 factorial, and we get 100 factorial divided by 80 factorial times 20 factorial, putting both of those in the numerator. And we're going to observe that 80 factorial is 100 minus 20 factorial, And of course 20 factorial stays what it is. Here's 100 factorial. And this expression puts everything in terms of just the 80 and the 100 and the 20. Okay, we don't have to invoke an 80. We see where it comes from by subtracting 20 from 100. And we understand from up here why we subtract 20 from 100 to get 80 factorial, to get rid of everything from 80 down to 0.